I'd say that, believe it or not, one of the most important things you're going to need to know for calculus is lines, meaning slope, perpendicularity, parallel, equations of lines, etc. And you need to know them cold. Now, you've studied them for a couple years, which is great. We're going to do a little review now, but they're going to keep cropping up. And then next year in calculus, at least during differentiation and when you're finding tangents to curves, you're going to need to know lines really, really well. So to begin with, we got to talk about slope. And if you've got certain lines, clearly you might say, if you were to describe the steepness of these two lines, you would say that L1 appears to be steeper than L2. Why? Because if you were riding a bicycle up, say, L2 slope, it would be easier than if you were riding a bicycle up, say, L1 slope. So we want to come up with some way to measure steepness, and that measurement that we've come up with is slope. And how do we find slope? Well, we're going to look for a change in y, which we call delta y, over delta x. And we know that we came up with finding slope by looking at a difference of y coordinates divided by a difference in x coordinates. And that clearly is going to lead to lines that rise from left to right are going to have positive slopes, and lines that fall from left to right will have negative slopes. Now, some important slopes. Certainly, if you've got a horizontal line, that seems to be kind of a special case of slope because there's no steepness. If you're riding your bike, it's flat, and you'd say, well, there's no steepness there. And then if we've got a vertical line, we say, well, unless my bike has got special suction cups or something, I'm not really able to ride my bike up a vertical hill. So if we think about then, if we look at our definition for delta y over delta x in each of these two cases, we note that for the change in y over change in x, there is no change in y here between 2 points, and there's some change in x between whatever points you pick, whatever that change is, call it d. And so if we're looking at 0 over d, 0 over any number is 0, and so our slope of a horizontal line is 0. With a vertical line, we note that they're using delta y over delta x again. Between any 2 points on that vertical line, there's going to be no change in x. So I'm then looking at some change in y between 2 points over 0 in the denominator. We know any number divided by 0 is not defined, so we say the slope of a vertical line is not defined. Now, that's true, but what happens if a line is really, really close to vertical? And we'll note that if we have that line really close to vertical, our delta x here, as the line gets closer and closer to vertical, the delta x gets smaller and smaller, so that in our delta y over delta x, that denominator is heading towards 0. And another important part of calculus that lies ahead we're going to look at limits. And in other words, if I were to look at this line, again, very steep line, the closer it gets to vertical, the smaller my denominator gets. And the smaller my denominator gets, remember, if your denominator decreases towards 0, the larger the whole overall number is going to get. So that should make sense. Smaller delta x, larger and larger overall number, and that some might say that the slope of a vertical line tends to infinity. In other words, it's an infinite slope. Infinity is not a number, so we say it's not defined. Now, when we're looking at parallel lines and things, and we're looking at slopes, I also want to point out that another topic that you studied in geometry turns out to be pretty important here. If I look at parallel lines, that means delta y here over delta x delta y1 over delta x2. If these lines are parallel, it means that delta y over delta x equals delta y1 over delta x2. Parallel lines will have equal slopes. And if that's true, then if I've got horizontal and vertical lines forming right angles, if I look at those two triangles that are formed here and here, I have similar triangles by the side angle side triangle similarity theorem. You might remember that from geometry. And we know if triangles are similar, then the ratios of the pairs of corresponding sides are proportional. We've already kind of used the two s's out of those. But more interestingly, we then get that these two angles here are going to be congruent because corresponding angles in similar triangles are congruent. And so looking at problems 29 and 30 that are assigned for you to look at, similar triangles come into play there. And you might want to remember that a couple other ways to prove triangles similar. You had the angle-angle similarity method, angle-angle triangle similarity, and you also had the side-side-side triangle similarity theorem. And those were your ways to prove triangles similar. Once you get triangles similar, then ratios of pairs of corresponding sides are proportional and corresponding angles are congruent. Okay, so for problems 29 and 30, 29 I've assigned as a homework assignment and 30 I've assigned as a bonus problem. Basically in 29, you're looking to show that two lines are parallel if and only if their slopes are equal. So that means that if you have parallel lines, then the slopes will be equal. And if slopes are equal, then you get parallel lines. And for 30, what you're looking to do, come on now. For 30, you are looking to prove, again, a two-way theorem, that two lines are perpendicular if and only if their slopes are negative reciprocals, meaning if you have perpendicular lines, then you get negative reciprocal slopes. And if you have negative reciprocal slopes, then you get perpendicular lines. So there's a part A and a part B, part B and a part C for each of those two problems, 29 and 30. And those are some proofs on, again, parallel lines having the same slope and perpendicular lines having negative reciprocal slopes.